However, hold on. First, didn't we, in section 2.3, talk about how many zeros a polynomial could have at most? We said they could have at most this many zeros. And we talked about these different examples of how parabolas might not even hit the x-axis, so then they don't have to have zeros. But what does this statement say? Polynomials of degree n have n zeros. Wait, n zeros? Yeah, but not just number, the degree, right? So for letter A, how many zeros, just looking at the degree, how many zeros does that f of x, according to the statement up above, have to have? 1. And letter B, how many does it have to have? 2. And letter C, how many does it have to have? 3. Now, look at your work. Did you get 1 and 2 and 3 for each of those?
Yes.
The difference in section 2.3, it did not say or even allow for complex zeros. Section 2.3 was rational, or I should say real zeros. Section 2.3 said at most n real zeros. This one says, hey, it's going to have n zeros, but some of them might be imaginary. So let's check it out and see if we found the imaginary ones. And letter A, set equal to 0. First of all, it should have 1, according to the degree. But set equal to 0, you solve, and what do you get as far as the placement of the zeros? You have a 0, x equals 2. And specifically, we could say 2, 0. Letter B, according to the statement up above, it has to have 2 zeros. What happened when you factored? X minus 3 times x minus 3. How many factors did it have? 2. How many zeros did it have, though? It's the same number, so some of you are going to make an argument and say there's only 1.
Multiplicity.
There is 1, but with the multiplicity one.
2.
2. Which, in essence, still lets the statement be true. Still lets the statement be true. Now letter C, I think this is kind of the weirdest out of all of them, because what happens when you factor? Yeah, eventually. But hold on, first when you factor, you just get x times x squared plus 4, right? And to find the zeros, let me put it on this side just to make it easier. Set the whole thing equal to 0. Now don't just go jumping places in your minds, because if you do, you're going to start making some mistakes and killing, I don't know, something. Probably ultimately puppies because you're trying to pretend that you can factor it. What do you do when you have factors equal to 0? Set each one equal to 0. So x equals 0, that's one answer. And the other one, x squared plus 4 equals 0. And some of you just accidentally said, oh, hey, that's x plus 2 times x plus 2. Or that's x plus 2 times x minus 2. But if you FOIL, are either of those going to give you x squared plus 4? No. Sadly. X plus 2 times x plus 2 gives you a middle term of plus 4x that doesn't have. And x plus 2 times x minus 2 gives you an x squared minus 4. Let's just try solving it. How would we solve? Subtract the 4, good. And then plus or minus square root, right? Why were we unable to see this before section 2.4? What kind of number is that? Imaginary. So it's plus or minus. How would we simplify that with imaginary numbers? Take out, change the square root of negative to an I, right? And then take the square root of 4, which is 2. So question. This one was supposed to have 3 zeros, right? And what do we have? 1, 2, 3. It's not 3 real zeros that were guaranteed. It's 3 complex zeros. Some of them will be real, aka we can really see them on a graph. And then some of them will be imaginary. They come out of factors, but not factors that you could see, or not values that you could see on a real Cartesian plane. Okay, with that, I just want to let you see a peek as to where we're going. Why is this not fun? Why is it worse than section 2.3? Section 2.3 would give you a 4th degree and say, hey, let's stop here and let's pull out like an x squared, right? But what's wrong with this one? Is there anything, any common factors common to all of them that we can pull out? And some of you are like, well, fine, we're going to group. Does anyone ever struggle with grouping when they don't even have the same number of terms? That don't work out so well. No. Not saying grouping will never work, but it rarely works with any polynomial of higher degree than 2. So thus, we're stuck unless we have some sort of way of approaching a problem. Okay, so section 2.5 is going to be a little bit intense, right? Look at this problem. It's a little intense, right? Is this homework due tomorrow?
No.
No. And to be honest, I think right now I have it due at Thursday. That's weird. Usually it would be like only 2 days, which will be Wednesday, right? So right now I have it due at Thursday. We're going to spend some time on this. We'll spend as much time as we need. If we can get it in, finish it tomorrow, that's great. But if we can't, then, okay. But if you notice, 2.5, he just got a little bit harder. And hopefully 2.4 wasn't too crazy. So if you guys look at your back board, what have I done as just a little break in the chapter? It's not a quest. It'll be worth 10 points. But what do I have tomorrow? A little quiz. On what? Sections 2.1 to 2.4. Why? They're easier than the end of the chapter. So let's get a good grade in. Let's have you guys review some of the basic foundational stuff to chapter 2 tonight. Don't even worry about starting 2.5 homework tonight. Don't worry about it. I have it due on Thursday. You have 2 other nights to work on it. Instead, we're going to grade our 2.4 homework. We'll see if you have any questions on 2.4 homework, the odds or the evens. And then tonight I want you to go back all the way from 2.1. It's just going to be a quick little 5-question quiz tomorrow. Each one worth 2 points, probably a bonus. It won't take all of class time. And you won't be able to use your calculator because they're going to be basic problems, okay? Like what? What was there in 2.4? Ah, good try. 2.4 was imaginary stuff. We're going to check that right now. And yeah, maybe some stuff to study, but hopefully not crazy hard. Don't worry, don't memorize that. 2.3, what was in there? Oh, synthetic and long division. You guys liked that homework, right? We can do that. Just review it a little bit. What was in section 2? Oh, okay. It was. I'm not saying it's easy, but easier than 2.5 though, right? 2.5 is going to be rough. Okay, let's keep going back. What was going on in 2.2? That's not going to be on the quiz. Don't worry. No intermediate value there. What else was on? Oh, multiplicities. Okay, you guys kind of got that today. Easier factoring. Easier zeros, right? Not as bad as 2.5. I'm not going to make you go all the way through. If you can't use a calculator, I'm not going to make you do this. I'm not going to make you do this. But I might make you factor and find the zeros. Okay. I might make you, oh yeah, end behavior, leading coefficient tests. Good thing to review. Not the drawing, not the sketching, but like the zeros, the end behavior, leading coefficient test. That's the main stuff from 2.2. And then what was in section 2.1? Parabolas. Oh, factoring. Good thing we reviewed that for a while, right? And then, oh, completing the square. Okay. But 2.1, factoring, completing the square, finding zeros, finding the vertex of a parabola. 2.2, leading coefficient test. What are the ends doing depending on the degree? And then factoring, finding the zeros, and multiplicity, pretty much. 2.3. What was 2.3? I got lost. Who has it? I totally just forgot. What was 2.3? Oh, synthetic division, long division. Perfect. And then 2.4, imaginary numbers. Okay, guys? So 5 questions. Imagine 1 per section-ish. 1 per section-ish. And then just one of the sections is going to have double. Okay? Probably kind of multiple parts, 2 points-ish each out of 10 total. 1 bonus. All right. go to 2-4. Let's check our evens. Let's see if we have any questions on odds. And then as we have time, we'll do a couple more things in 2-5, but we're not going to totally go crazy. Mason, go ahead, bud.
Are you going to collect all the
No. For the quiz, I'm not collecting your spirals. I'm not collecting your notes. Probably should, so have it ready. That's scary. Need an intervention over here. But if you don't have to do 2-5, even start it tonight, my advice would be practice the other stuff. You're just smiling. Okay, so 2-4. Practice, practice. And review. All right. Number 6, complex conjugates. We didn't talk about complex being the first name of it, but hopefully you guys saw it in this section. They are complex and then they are conjugates, multiplied by the conjugate. Number 8, easiest problem ever. Some of you might have overthought it though. A is the first piece, 13. B is the second piece, 4. Done. I know, right? It was so easy, it was hard. Does it make sense now? You're just looking at the form and saying, who's who? I know. Number 26. You didn't kill anything, right? 3 minus, okay, at least the seals stay alive? Negative 3 minus 11i. Number 40. You didn't kill a puppy, did you? Did you write it out? Did you FOIL it? You had to FOIL it, and then the I squared became a negative 1 with a 16, and then you had to simplify. 9 minus 40i. Don't worry, if you got it wrong, write it down. Just study it for tomorrow. Wayne, that's a pencil, not a pen. Number 52. Uh-oh. We had to simplify. Now this one was a little bit messy. Because you could just do an I. You could have just done an I. They went ahead and saw the 2 and saw the negative, and they did all this extra stuff. But did you guys, either way, even if you just did times I over I, did you simplify it at 7i? Positive 7i. I squared changes into a negative. Positive 7i. Oh my goodness, that was it? They did it funny. They did the negative. But even if you did the I over I, it'd be negative 14i over 2i squared. That'd still be 14 over 2 is negative 7, but I squared is a negative 1, so positive 7i. You could have just done the I over I trick. Justin. Number 9. Okay, who else? Any other odd questions? Austin. 30, which one?
3.
Oh, I see. 61. Anybody else going once? Going twice? I'll take volunteers who don't have points yet. Abby, which one do you want? 9 is yours. Yeah, 33. It's yours? Oh wait, Justin already has one. Anybody else want it? Caleb. Got it. Alright, kiddos, come on up. Grab from the box on the chair. I think that's you guys, right? 3 and 2? Okay. Let me pause the recording. Look at the big ideas. Is intermediate value theorem on there? No. Right? Don't stress about intermediate value theorem. Do you have to like make a table with yucky numbers and sketch and graph? No. You don't. But the basics. 2-1 to 2-4. Sound good? Do you even have to start this somewhere? Okay, here we go. How on earth does this page of blah help us with that?
But you're going to tell us.
Because it tells us. The only rational zeros of a polynomial are going to be in the list of possible zeros that come from this little baby equation. So any of the zeros that come out of the factors have to be included. Any of the rational, any of the nice zeros, the ones from like easy factors, have to be found from all the different factors of the last term, if that helps. All the different factors of the last term, or the constant term, over all the different factors of the first term, or the leading coefficient. So from this little equation, we're going to form a list of all our possible rational zeros, and either by plugging in or by synthetic, whichever one's easier for the number that we have. We're going to test them and hopefully find at least one good one, break it down, our polynomial with synthetic, and then hopefully have an easier piece to factor or an easier function to factor. So we're going to get this one example done pretty much, and that'll be it for today, okay? Our little formula says for possible rational zeros, before we do anything, we consider the possible rational. If you want to think about it, the possible nice zeros. Not imaginary, not nasty decimals that don't correspond to a fraction or a whole number. We take the polynomial that they've given us, and we say, what are all the different factors of the last term? And what are all the different factors of the first term? And put a plus or minus in front. So, what are all the factors of 6? 3, 2, 6, and 1. Just to be nice and neat, I'm going to go ahead and always put them in order. So 1 goes into 6, 2 goes into 6, 3 goes into 6, 6 goes into 6. The nice whole number factors of 6. What do you think the prime factorization of 6? No, not just the prime factors. All the factors. Stink! Who's the leading coefficient, guys?
1.
That's it? Oh, that's easy. Now how do we take the little formula and how do we actually get our list of possible zeros? We simplify. Remember how we can divide each and every piece? And there's not plus or minus. This isn't like an equation. It's just saying, hey, what's 1 over 1? Oh, just 1. 2 over 1, just 2. 3 over 1, that's just 3. 6 over 1, those are our possible, the only possible for this very polynomial. Those are the only possible numbers that could work for nice factors. Now, we could do 8 different synthetic divisions. How's that sound? Sound fun? Or we can ask ourselves a question before we even start synthetic divisions, unless you really like them, then go do 8. Maybe we can plug in the small numbers just in case they're easy. And they're only going to go in perfectly if the function, which is the same thing, remember, as the remainder, is what? 0. So if I plug in at 0, it's going to work. I'm going to go do synthetic. If I plug in and it's not 0, it doesn't work. I'm not going to do synthetic, and I can narrow it down a little bit. So if I plug in 1, what happens? 1 to the 4? Minus 1 plus 1 minus 3 minus 6. Why? 1 times anything positive 1 stays the same. Those cancel. That's not 0. Right? It doesn't matter what it is, it's not 0. Okay, forget that. I don't want to plug in 6 or 3 or 2, do you? How about negative 1? Maybe he's not as bad? I usually plug in the little ones. Negative 1 to the 4. Is it? That's a positive 1. Minus, what's negative 1 cubed? Negative 1. Plus 1. Minus 3 times negative 1 is plus 3. Minus 6. 1 plus 1 plus 1 plus 3. 6 minus 6 is? I know, sometimes plugging in is dangerous because there's a lot of mistakes that can happen. So maybe you're not going to want to plug in very much. But I just found a 0 and I saved myself a synthetic with this guy that doesn't work. So now I can say, hey, let's do synthetic. Let's do it with the one that works, yeah? Plugging negative 1 into the box. If you think about it, remember, if A is negative 1, we're dealing with the factor x plus 1. My coefficients, right? We need those. So 1, negative 1, 1, negative 3, negative 6. Oh, come on. We can do synthetic. No stress. Yes. Okay, bring down the 1. Negative 1. Negative 2 times negative 1. That's 3 times negative 1. That's negative 6 times negative 1. That's just like we thought. Not gorgeous, but it worked. Now, kiddos, this, which was a fourth degree, when divided by x plus 1 becomes who? What is this function now? Third. Okay. Is it exactly where we want it? It's closer. What do we want to be able to factor and like have control over? We want a quadratic, yeah, we want a squared. So we're closer. We went from a fourth degree to a third degree. That's good. But what we need to do? Keep going. Depending on, I'm not exactly sure how Mr. Park taught it, but depending on who you had last year, they might have said, hey, just steal these coefficients and why don't you go again with another number? That's one way. But do you remember how I told you guys, every now and then, grouping works. Every now and then. Every now and then, grouping works. So then we could end up with, hold on, who was there in the beginning that we took away but we need to put back in if we're trying to include everybody? -1, which comes from x plus 1. This is the same thing as my function, and we'll get back to this after. This is not 1 to 2, 4. The fundamentals, not the crazy little things that intermediate value here.
On a scale of 1 to 10, how bad is this by doing like
Really?
This is just a hypothetical
Yes, every day.
question.
It's purely hypothetical.
Purely hypothetical.
Like on a scale of 1 to 10.
You'd say it's like
It's okay as long as your natural intelligence says you never need to listen to class, but
Hey,
Natural intelligence.
I'm never gonna be ready to do them on the board, so.
natural intelligence.
Dang, roasted.